We're now going to provide definitions about sequences and series. And so these are going to be used quite heavily through the next chapter, and so we need to make sure we understand what we're talking about. A sequence is a list of items. In this case, specifically in a math class, so that's a general term, it's a list of numbers. And an infinite sequence is a sequence that has a domain of all positive integers. So that when we talk about the first entry, the second entry, the third entry, it goes on and on and on forever. A term is an individual element of the list. And we usually denote it as an a sub I, where the I says which term. The nth term, said an, is used to denote what we call the general term. And the general term is the one we have to find. So give n and get an. It works similar to a function. In fact, that's the general term here. So the nth term and the general term are usually used interchangeably. So again, this is an, the nth term, and it's what we use to find specific terms. A finite sequence is simply a sequence with an end. It just has a limited number of terms. And we'll talk about a few of these as well as we go. The recursive form is when a sequence, or rather an element of a sequence, depends, that's an awful way to write element, let me rewrite that. So the element of a sequence that depends on previous terms. So in order to know the next one, you have to know the current one, and so on and so forth. The Fibonacci sequence is a famous sequence given by Fibonacci, and it starts with 1 and 1, and then each new element depends on the sum of the two before it. So 1 plus 1 is 2. Then this one depends on the 1 and 2, which is 3, and then 2 and 3, which is 5, and 3 and 5, which is 8, 5 and 8 is 13, and it just goes on. So it's an infinite sequence that allows us, it models a lot of things in the real world, actually. A factorial is a special operator that says, so we define it as n factorial, we use the exclamation point. This is defined as n times n minus 1 factorial. So we multiply it by all of the numbers less than it until we get down to the 0 factorial, which the definition of 0 factorial is 1. And so you need to know this. This is a specific definition, and it's why factorials work. Summation is a way of adding terms together, and it looks like the following. So we've got a bunch of definitions that are going to depend on this. We use this sigma symbol as the summation. We get an AI here, we're adding some terms together, and then we list I equals some number A, and it goes to some number N. So on the next page I have some more definitions that relate to this. This is the summation. The I is the index of summation. It's what changes here every time. This is called the upper limit of the summation. This is called the lower limit. So it starts at the lower limit and adds everything from the lower limit to the upper limit, going up by integers. So that's the upper limit and the lower limit. And the series by definition, is what we call the sum of all of the terms in a sequence. So these we've already covered, that was done above, but the series is the sum of all terms in a sequence. And then the nth partial sum is the sum of the first n terms in a sequence. So a series is specifically when we start summing together the sequence, and a sequence is just a list of numbers. But these are all the definitions that you need to know.